Are we alone? I mean, really, is there anyone else out there? It's a question that's haunted us, right? But here's the thing. To find an answer out there, we actually have to start right here. We've got to unravel the completely wild, improbable story of how we even came to be. So let's get into it. This is a real cosmic detective story.
Just let that sink in for a second. In an infinite universe, there must be other life. It almost has to be true, doesn't it? So maybe the question isn't if there's life out there. The real mystery, the big puzzle, is how. How did it happen, and where on Earth, or off it, do we even start looking?
Okay, so to have any hope of finding life somewhere else, we've got to first figure out the recipe that made us. And, our story, it doesn't start gently. It kicks off with a massive, planet-shattering collision.
So how did that happen? How does a dead, barren rock like the early Earth turn into, well, this, a world teeming with life? The answer, it turns out, was anything but gentle. It was an impact so unbelievably violent it literally changed everything for our planet.
This whole idea is called the giant impact hypothesis. And it goes like this. About 4.5 billion years ago, a protoplanet roughly the size of Mars, we call it Theia, just slammed right into the early Earth. We're talking about an impact so huge that it melted both planets, squishing them together into a new, bigger Earth, and all the debris that got blasted out into space, that's what eventually became our moon.
And these kinds of cosmic collisions aren't just some wild theory. We see evidence of them. For Earth, this incredible smash-up wasn't the end of the story. No way. It was the beginning. It didn't just give us a moon to look at in the night sky. It delivered the actual critical ingredients that made life possible in the first place.
Yeah, believe it or not, this disaster came with some amazing gifts. First, we got our big moon, which is super important because it stops Earth from wobbling all over the place, and that stabilizes our climate. The impact also knocked our planet sideways, giving us our axial tilt. The reason we have seasons. And maybe the most important gift of all, scientists are pretty sure Theia was like a cosmic delivery truck, dropping off a huge payload of carbon and nitrogen, the literal building blocks of you, me, and everything alive.
But wait, that just kicks the can down the road, right? If Theia brought us these ingredients for life, where did Theia get them from? For that answer, we have to zoom out, way out, beyond our solar system and look at some of the most powerful, most creative events in the entire universe, the explosive deaths of giant stars.
So think about a massive star. For its entire life, it's basically in this epic tug-of-war with itself. You've got gravity, this immense force just trying to crush it, squeeze it into a tiny ball. But at the same time, deep in its core, nuclear fusion is creating this incredible outward blast of energy, pushing back against gravity. It's a perfect, delicate balance.
But that balance can't last forever. Eventually, the star starts to run out of fuel. The fusion engine sputters and dies. And in that instant, gravity wins. It causes a sudden, catastrophic collapse, which then triggers these enormous shockwaves that rip the star apart, blasting its outer layers across the galaxy in this one titanic explosion, a supernova.
And these explosions, they're basically cosmic forges. The heat and pressure are so intense that they create all the heavier elements on the periodic table. We're talking about everything from the carbon in your body to the iron in your blood. And then the supernova scatters all that precious stuff across the cosmos, like a farmer sowing seeds for new stars, new planets, and maybe, just maybe, new life.
All right, so we've got the ingredients. We know they're everywhere, thanks to these stellar explosions. So the obvious next step is to look for life around stars just like our sun, right? Makes sense. Well, what if I told you some scientists are looking in a totally unexpected, kind of spooky place, the graveyards of dead stars?
Let me introduce you to the white dwarf. Now, this isn't really a star anymore. It's more like a star's ghost. It's what's left over after a sun-like star runs out of fuel and gently puffs away its outer layers. What's left behind is this super dense, glowing hot core. It's like a cosmic ember just sitting there, and it's going to take trillions of years to cool off.
I know what you're thinking. How could anything possibly live around a dead star? I mean, it sounds crazy, right? To get any warmth, a planet would have to orbit incredibly close to it. But if you think about it, the possibilities are actually fascinating. Check this out. A planet in just the right spot around one of these cooling white dwarfs could stay in the habitable zone, that perfect region for liquid water, for up to 8 billion years.
that is almost double the entire time Earth has been around. Think about that. What an incredible amount of time for life to get started and evolve.
Okay, so the ingredients for life are literally scattered everywhere. And the number of potential homes for life, it's way bigger than we thought. So that brings us to the next big question. If life's out there, has it tried to say hello? Are we getting any visitors?
Our solar system isn't some lonely island. We get visitors. We've now confirmed at least 3 objects that have swung through our neighborhood from other star systems. They're like little messengers from distant stars, and boy, have they raised some interesting questions.
And with every one of these visitors, there's this big debate. On one side, you have scientists saying, look, it's a comet, it's behaving exactly like a comet from our own solar system, it's totally natural. But on the other side, some people look at their weird trajectories, their incredible speed, and they can't help but wonder, could this be something else? Could it be artificial? So, we're not just passively looking for these visitors, we are actively listening. Scientists are pointing giant radio telescopes at the sky, and they're listening for what they call a technosignature. Think of it like this. The universe is full of natural radio noise like static. A technosignature would be a single, clear station coming through all that static, a focused signal that just screams technology.
And I want you to understand the scale of this search is just mind-boggling. You've got projects like Breakthrough Listen, using the most powerful telescopes on the planet to scan millions upon millions of stars, and even 100 nearby galaxies, all listening for that one single beep. This is, without a doubt, the biggest hunt for aliens in human history.
But this whole cosmic search for stable, intelligent life out there in the universe, it has a final, pretty dramatic twist. Because it forces us to look back at ourselves right here on Earth. And what we find is another incredibly fragile balance, one that feels eerily familiar to the cosmic luck that allowed us to exist in the first place.
Okay, so this is something called the Atlantic Meridional Overturning Circulation, or AMOC for short. It's basically a giant global conveyor belt in our oceans. It's a critical life support system that moves warm water around, regulating the climate for the entire northern hemisphere. In the same way our moon gives us that cosmic stability, the AMOC gives us climate stability.
So what would happen if that conveyor belt just stopped? Well, this number, minus 10 degrees Celsius, that's the potential drop in average winter temperatures across a huge chunk of northern Europe and North America. We're talking about a massive shift to a much, much colder and more extreme climate.
And look, this isn't some sci-fi scenario for 100 years from now. Scientists have measured it. The AMOC is weaker right now than it's been in over 1,000 years, mostly because of melting ice caps pouring fresh water into the ocean. Now, there's debate on the timing, but some studies are warning that we could hit a tipping point, a point of no return, alarmingly soon. The very system that makes our world so livable is becoming unstable.
So here we are. Our entire existence is the result of this incredible, fragile chain of events. A chance planetary collision, the explosive death of a star billions of years ago. It's a miracle we're here at all. And as we keep searching the cosmos, looking for signs of intelligence out there, this whole cosmic detective story kind of forces us to ask one last really big question.